Very good morning to everyone. Today's subject of discussion is limit test for heavy metals. This is a test which is used to detect the presence of heavy metals and also to know whether these heavy metals are within the prescribed limits of Indian pharmacopoeia. As we know that limit tests are based upon the reaction between the reagent what we add and the impurities that are present in the given substance reacts to give a visible coloration or turbidity, and it is compared with the standard solution which is prescribed by the Indian Pharmacopoeia. If its coloration or opalescence is lesser than that of the coloration or opalescence produced by the standard solution, then it passes the limit test. Here in heavy metals, we are treating with sodium sulfide or hydrogen sulfide. Sodium sulfide is Na2S, hydrogen sulfide is H2S. The heavy metals present in the given sample as impurities in trace amounts reacts with the hydrogen sulfide or sodium sulfide which is used as a reagent, and it gives a colored precipitate under standard test conditions. And this is the principle behind the limit test for heavy metals. The color precipitate which is formed, we compare with the standard solution. And if it is lesser than that of the standard, it passes the limit test. It indicates it is within the limits. Various heavy metals reacts with hydrogen sulfide and sodium sulfide. The heavy metals include iron, copper, lead, nickel, cobalt, bismuth, antimony, etc. The heavy metals are indicated in the Indian Pharmacopoeia in terms of parts per million. That is, the parts of lead per million parts of substance. If the substance is in 1 million, the number of parts of lead present in it is usually 20 parts per million for heavy metals. Indian Pharmacopoeia adopts three methods to perform the limit test of heavy metals. These three methods are used for different types of substances. The first method is used for those substances which gives clear colorless solution in when the specified reaction conditions. And second method is used for those substances which do not give clear colorless solution under standard specified conditions. If it those substances, if it dissolves in water and gives clear colorless solution, method 1 is used. If it do not give clear colorless solution, method 2 is used. It all depends upon the solubility of the substance what we use in the water under standard specified conditions. That is the pH, temperature, etc. Method 3 is used for those substances which gives clear colorless solution in basic medium or in some sodium hydroxide medium. Three methods have been prescribed for the limit test for heavy metals in the Indian Pharmacopoeia. The heavy metals present in the substance reacts with hydrogen sulfide or sodium sulfide. Lead is an heavy metal. We take lead as an example. Lead react with hydrogen sulfide. Hydrogen sulfide is a gas. That gas which is produced, we pass into water to get the saturated hydrogen sulfide solution. That hydrogen sulfide solution is made to react with lead. The lead combines with sulfur to give lead sulfide and hydrogen gets liberated. The lead sulfide which is formed gives a coloration which will be brownish in color, and it is compared with the standard. Instead of hydrogen sulfide, we can also use sodium sulfide. If it has lead in the form of lead chloride, it reacts with sodium sulfide and it gives rise to lead sulfide and sodium chloride. Sodium chloride dissolves in water and lead sulfide precipitates, and that gives a colored precipitate. The procedure which we follow is here is like this. We prepared the sample solution as per the prescription of Indian Pharmacopoeia, and 25 ml of this prepared solution is transferred to Nessler cylinder. The standard solution which is prepared, 2 ml of it is taken and is diluted to 25 ml with water and transferred into the Nessler cylinder. Then the test solution and the standard solution, which contains the sample and the standard lead solution, is the pH of it is adjusted to 3 to 4 range by using either ammonia or acetic acid solution which is specially prepared for it. Why it is should be specially prepared? The ammonia and acetic acid what we use should be free of heavy metals. That's why you mention it as SP. SP stands for specially prepared or specifically prepared for the limit test. The solutions 25 ml which we have taken in test solution, the samples is dissolved, and in the standard solution, the standard solution has been prepared and is diluted to 25 ml at its pH is adjusted to 3 to 4 range. Then both the test solution and standard solution is diluted with water to 35 ml. This is followed by addition of 10 ml freshly prepared hydrogen sulfide solution. And the volume is made to 50 ml by addition of water. The prepared solution which is made to 50 ml is kept aside for 5 minutes for the reaction for completion. Then it is viewed from downwards, from the upside, against a white background. And the coloration produced in this test solution and the standard solution is compared. If the test solution has lesser coloration than that of the standard, then it passes the limit test. The second method is used for those substances which do not give clear colorless solution in water. The standard solution is prepared in the similar way to that of the method 1. This test solution requires treatment as they are not easily soluble in the water. We weigh the specific quantity of the substance in a crucible and we moisten with small amount of sulfuric acid and we ignite the mixture taken in the crucible and moisten with sulfuric acid in a low flame. We ignite until it gets charred. To this charged substance, we add few drops of nitric acid and heat the mixture to 500 degrees centigrade. After heating the mixture to after adding nitric acid to 500 degrees centigrade, we cool to room temperature and we add 4 ml of HCl and we heat it again until the whole HCl gets evaporated and gives a dry solid. Then again we add 10 ml HCl and digest it or dissolve it by triturating with the help of a glass rod, and whatever the substance get dissolved in it, then we neutralize with ammonia solution and acidic acids and made acidic pH 3 to 4 with acetic acid, and again we filter. If anything insoluble substance are there, it can be removed. The filtrate which is formed is taken into the Nessler cylinder and the volume is made up to 35 ml with water. To the resulting solution, we add 10 ml of hydrogen sulfide solution and make up the volume to 50 ml, and the color which is produced is compared with the standard solution. The standard solution is prepared in the similar method as that of method 1. But test solution we prepare in a different way because these substances are not fully soluble and do not give clear colorless solution in water. To make it clear, give colorless solution, we treat with sulfuric acid followed by nitric acid and followed by HCl, and it is digested with HCl neutralized to pH 3 to 4 by using ammonia and acetic acid, and the other procedure is followed in the similar fashion of the test 1 or the method 1. In method 3, these are the substances which gives clear color solutions under basic condition. Method 3 can be used for this. We take the specified quantity of substance as prescribed by Indian Pharmacopoeia and add 20 ml of water and 5 ml sodium hydroxide solution, and the volume is made up to 50 ml in the Nessler cylinder. Standard solution, we take 2 ml of standard lead solution, 5 ml of sodium hydroxide solution, and the volume is made up to 50 ml in the Nessler cylinder with water. To this solution which is prepared, we add 5 drops of sodium sulfide to both the test solution and standard solution, and we mix with a glass rod and we keep it aside for 5 minutes. The sodium sulfide reacts with the heavy metal impurities present in the substance and it gives a coloration, and if this coloration produced is lesser than that of the standard solution, it passes the limit test. And heavy metals are also present in the volatile oils, and for the knowing the that heavy metals in this volatile soil are within the limit, we conduct limit test for heavy metals in volatile oils. In a 25 ml stoppered tube, we take 10 ml of volatile oil 10 and add 10 ml of water to it and 1 drop of HCl, and it is shaken well. Then to this solution, we pass H2S gas directly In the limit test for heavy metals for other substances, we prepared saturated solution of hydrogen sulfide, and that 10 ml of that saturated solution we added. But here hydrogen is gas is passed into the volatile oil mixture until it is saturated. If there is no darkening in color, either in oil phase or in aqueous phase, then it passes the limit test. The volatile oil, when it is added and treated with HCl, it gives some coloration. And if that coloration is not increased by passing H2S gas, then it passes the limit test. This is how the limit test for heavy metals in volatile oils is conducted. We are not using any standard solution for comparison. It's only a single test solution which you are preparing. Reagents are prepared in a specific manner. Dilute acetic acid is prepared by diluting 57 ml of glacial acetic acid and made up the volume to 1000 ml with water. It approximately contains 6% weight by weight of dilute of acetic acid. Strong ammonia solution, it contains 10% weight by weight of ammonia. It can be prepared by diluting 425 ml of strong ammonia solution to 1000 ml, and it should be placed in a well closed container in a cool place. Standard lead solution, 0.1% lead solution is prepared by dissolving zero point 0.4 grams of lead nitrate in water containing 2 ml of nitric acid, and it is diluted with sufficient water to produce 250 ml. Standard lead solution, 100 parts per million, is prepared by diluting this 0.1% lead solution which you have prepared by taking one volume of it and diluting with 10 volumes with water. The standard lead solution, 20 parts per million, is prepared by taking the 100 ppm standard lead solution one volume, and it is volume is made up with 5 volumes with water. We get 20 ppm lead solution. The standard solution of hydrogen sulfide is prepared by using special apparatus which is named after a scientist who gave this apparatus. It is called a Skips apparatus. In the Skips apparatus, we take ferrous sulfide sticks and it is made to react with equal volumes of concentrated HCl and water. Ferrous sulfide, FeS, reacts with 2 moles of HCl, and iron combines with chlorine to give FeCl2, and hydrogen combines with sulfur to give hydrogen sulfide. Hydrogen sulfide being the gas, that is that gas which has come goes out with, and this H2S gas which is produced are passed into water to get the saturated solution of hydrogen sulfide. We use freshly prepared hydrogen sulfide solution for conducting the limit test of heavy metal. This hydrogen sulfide has a strong pungent odor of rotten eggs. This hydrogen sulfide, as it has a rotten egg smell, a strong pungent odor, to avoid this, we can use thioacetamide in place of hydrogen sulfide. There is another method which has been prescribed by the Indian Pharmacopoeia. This is all about the limit test for heavy metals in brief. Let us look into the limit tests of other impurities in the coming presentations. Till then, have a nice day. Thank you.